So in this third topic in the third module, what we should understand first is what is the concept of system type and system order. So two things I would like to tell you that for a system, it is given that forward path gain is GS. Okay, so it is 1 by S and feedback gain is HS equal to 1. So this document also I'll upload to you. Very good document I have prepared. So if you understand this document, you will understand everything about what is meant by system type. And system type is very important concept to understand what is called as system steady state error. So today also we will see steady state error and what is the relationship between system type and system steady state error that we will explain today. So for a system, it is given that forward path gain GS is equal to 1 by S and feedback gain HS equal to 1. There is a concept called as open loop transfer function. So it is explained here clearly what is meant by open loop transfer function. It is forward gain multiplied by feedback gain, that is 1 by S into 1 is 1 by S. Now the same system, whenever you are trying to find the closed loop transfer function, it will be GS divided by 1 plus GSHS. You assume this thing to be a negative feedback system, so that's why this is plus. So in that case it is GS, that is 1 by S divided by 1 plus 1 by S into 1, that is GSHS. So if you rationalize it, it becomes 1 by S plus 1. So where is the zero of the system? There is no zero. Okay, so first we had been finding what is open loop transfer function. So this concept is very important. Understand it, because in the fourth module we will require this. What is meant by open loop transfer function? It is GS into HS. And what is closed loop transfer function? We are denoting it by TS. So TS is equal to GS by 1 plus GSH. This is 1 by S plus 1. I was talking about where is the zero. So there is no zero in the system. There is a pole, no zero, because numerator is having only 1. So numerator is not a polynomial in S. Whenever there is a polynomial, there will be a root, and whatever is the root of numerator polynomial, that is called as 0. 0 does not mean I'm not talking about the point 0, 0 in S plane. I'm talking about 0 means whatever are the roots of numerator polynomial, that is called as 0. And whatever the poles of denominator polynomial are there, that is called as poles. Okay, so in this case, we are finding closed loop pole is that S is equal to -1. Where is the open loop pole? So you can find out what is OLTF. So OLTF is 1 by S. So there are two concepts. You have to understand it very clearly. So open loop pole is that S is equal to 0. What is the open loop transfer function? GS into HS. So what is the open loop transfer function? 1 by S. If you see S at the denominator, where is this S situated? This S is situated at S is equal to 0. That is called as origin. Okay. So open loop pole changes in closed loop pole. So open loop pole is S is equal to 0, that is S at origin, but closed loop pole is equal to S is equal to -1. So this is another example of explaining how a open loop transfer function system becomes stable in closed loop. So whenever I'm saying open loop pole, this is that S is equal to 0. So S is equal to 0 or origin is a critically or marginally stable system. Okay, so if you are finding that open loop transfer function is a marginally stable system, but whenever you are making it closed loop, you are finding that S is equal to -1. That means the closed loop pole is shifting to the left hand side of S plane. So this is another example of explaining how the closed loop negative feedback, it makes the system more stable. So you understand this concept. Open loop transfer function is having pole at S is equal to 0, that is at origin. When we are making the closed loop pole, that is GS by 1 plus GSHS, obviously it has to be negative feedback. In that case, it is becoming 1 by S plus 1. That means S is equal to -1. That means the open loop pole of S is equal to 0, which was marginally stable, it is shifting to S is equal to -1. So it is becoming a stable pole. It's okay, Akshata, no issues. So, but one more thing you can find out, if I'm putting a positive feedback in this case. So if I'm putting a positive feedback, this will become 1 minus. Okay, so it will become 1 minus. That means it will become 1 minus. So this will become S minus 1. If it is becoming S minus 1, in that case, S will be equal to 1. That means the system will become unstable. So only by these three lines, very important concept of control system you can understand. That is, first is open loop transfer function. So GS into HS, GS into HS is called as open loop transfer function. This is not having any physical implication, but it is having tremendous theoretical implication. So from this open loop transfer function, I am finding S is equal to 0. That is, pole is at origin. Now I am finding first what is the closed loop transfer function. I am finding closed loop pole is at S is equal to -1. So this marginally stable system is now becoming perfectly stable system. S is equal to -1 with negative feedback. But if I put positive feedback, this will become 1 minus GSHS. In that case, denominator will be S minus 1. If this is becoming S minus 1, in that case, where will be the closed loop pole with positive feedback? In that case, S is equal to will be at plus 1. S is equal to plus 1 is a unstable pole. So from these three lines, you are finding the whole understanding of open loop gain and how the open loop is becoming stable with negative closed loop feedback. Now we are actually doing this document for what is the concept of type and order. Order is generally found for a closed loop transfer function Ts. So Ts we are finding denominator equation power of s is equal to 1. So here it's a polynomial. Okay, here is a polynomial. So 1 by s plus 1. Okay, so this is a polynomial. In this polynomial, find out what is the maximum power of s. So maximum power of s is equal to 1. So from open loop transfer function, I will talk about type later, but from closed loop transfer function, you are finding the highest power of s at the denominator polynomial is 1. That means this is a system with order 1. Okay, so this is how to find out system order. So open loop GS, open loop HS will be given to us. Multiply GS into HS and find out what is the transfer function, what is the characteristic equation. Characteristic equation, you can find what is the closed loop pole. So closed loop pole, in this case we are finding s is equal to minus 1, that's a stable pole. And in this polynomial, what is the order of the s denominator polynomial? So we are finding that to be 1. That means order of the system is equal to 1. Now let us find out what is meant by type. Okay, so type is actually found from open loop transfer function. So I can go up. Open loop transfer function is 1 by s. In this 1 by s, in the denominator, so I'm defining type. In the open loop transfer function, in the denominator, you have to find if there is any separate s. Okay, so there is a separate s, and what is the power of that? Power of separate s is equal to 1. And in this case, so type of the system is found from open loop transfer function. Why do we require type? Because the system steady state response, steady state error depends on what is the type of the system. So what is the definition of type? In open loop transfer function, whatever number of s is there at the denominator which are there at origin. This is at origin because s is equal to 0. So how many poles are there in open loop transfer function GSHS which are there at origin? That is actually equal to the type of the system. So we are finding here it is 1 by s. 1 by s means there is only one pole and that pole is at origin. That means what is the type of the system? Type of the system is 1. So two things I will tell you. First thing is type is found from open loop transfer function and order is found from closed loop transfer function. So open loop transfer function is given by GSHS. Closed loop transfer function is given by GS divided by 1 plus GSHS. So this is the first difference between order and type. Second difference is what is meant by order. In the closed loop transfer function, find the denominator polynomial. Whatever is the highest power of s in the denominator polynomial of closed loop transfer function, that is called as order. So in this case, closed loop transfer function is denominator equation s plus 1. Maximum power of s is 1. In that case, the order of the system will be 1. So it is given here, CLTF closed loop transfer function. Order of the system is the highest power of s in the denominator polynomial is equal to 1 here. That's why order of the system is equal to 1. What is meant by type? Type is nothing but how many poles are there at the origin at open loop transfer function. So open loop transfer function is 1 by s. Here we are finding there is only one pole and that pole is lying at origin. Okay, hence we are calling that type of the system is equal to 1. Let us say another different example. Okay, so all this example when you read, you will understand what is the concept of type. So for a system, it is given that, so there is a next example, GS equal to 1 by s plus 1 and HS equal to 1. What is open loop transfer function? It is 1 by s plus 1 into 1, that is equal to 1 by s plus 1. So how many poles are there at the origin for the OLTF? So there is only one pole in the OLTF. OLTF is GS into HS. Okay, and closed loop transfer function CLTF is G divided by 1 plus GH. So OLTF is 1 by s plus 1. Where is this pole situated? This pole is situated at s is equal to minus 1. Is there any pole for OLTF which is there s is equal to 0? There is none. Okay, so here there is only one pole and that pole is at s is equal to minus 1. So now in this OLTF, is there any pole which is there at s is equal to 0? There is no pole which is there at 0 for OLTF. Hence, the system is having type is equal to 0. Okay, so in this case you have to check OLTF. OLTF is 1 by s plus 1. So there is no s here. Previous case, if you check previous case OLTF, what was that? 1 by s. That means there was one pole which was at origin. But if OLTF is 1 by s plus 1, what is OLTF? GS into HS. So GS in this case is 1 by s plus 1, HS equal to 1. So OLTF is 1 by s plus 1. There is one open loop transfer function pole, but that pole is at minus 1. Okay, but there is no pole for OLTF which is exactly there placed at origin, that is S. So in this case, no separate S in the OLTF denominator. So there should be a separate S term. Okay, only S. There is S square, S cube, likewise. Okay, there is no separate S term in the OLTF denominator. Hence, the system is having type is equal to 0. So we can say that this is S raised to 0 into S plus 1. S raised to 0 is nothing but 1. So when there is no separate S means separate S is actually situated at the origin. So there is no separate S at the OLTF in this example. Hence, type of the system is equal to 0. Now you find GSHS and then find GS divided by 1 plus GSHS with negative feedback. What we are finding is open loop transfer function is having pole at S is equal to minus 1. And when you are finding TS, that is GS by 1 plus GSHS, you are finding closed loop with negative feedback, the pole is at S is equal to minus 2. So this is another example which proves that the closed loop actually is giving me a more stable pole with negative feedback. Because open loop pole was there at S is equal to minus 1, which was closer to j omega axis. And we know that the pole, if it is deep into j omega axis, it is more stable. So in this case, CLTF, that is a closed loop transfer function, is equal to 1 by S plus 2. So S is equal to minus 2. So open loop pole was at minus 1, closed loop pole is at minus 2. That means this is more stable. So this also proves that negative feedback closed loop system actually improves the system stability. So this is another important thing. And what is the order of the system? So you are finding denominator polynomial is S plus 2. So S plus 2 is nothing but power of S is equal to 1. So this is for CLTF. We find a type from OLTF and we find order from CLTF. Very important concept. It's not this clearly written in any book, hence this my note is very properly done. Try to understand. So OLTF is giving us type. So in this case we find what is the type of the system. So it is S raised to 0 into S plus 1. So there is no pole at origin in OLTF. That's why this is having type of the system as 0. So there are mainly three types of system: type 0, type 1, type 2. So what is a type 1 system? This is a type 1 system which is having GSHS as 1 by S. That means there is one pole at origin for this system, OLTF. But here in the second system, you are finding that there is no pole at origin in GSHS. That means the type 0 system, and previous system was a type 1 system. This one. The first one system was a type 1 system. Second one system is a type 0 system. And what is the order of the system? Order of the system is also 1. So this system is a type 1 order 1 system. Previous system was a next system is type 0 order 1. So here it is written type 0 and order 1. So CLTF is having S plus 2. So this is type 0 order 1 system. Previous system was type 1 order 1 system. Now let us see something of another example. So in this case, GS equal to S by 2 S square into S plus 2, and feedback gain HS is equal to S. So multiply them. If you are multiplying them, what you are finding is GS into HS. So OLTF is given by GS into HS. If you are multiplying that, so this S and denominator S, they are getting cancelled. Okay. So in that case, you are finding that OLTF is equal to S plus 1 divided by S into S plus 2. So how many open loop poles are there? There are 2 open loop poles. Okay, so OLTF is having GSHS S plus 1 S into S plus 2. There are 2 open loop poles. One open loop pole is there at origin, S is equal to 0. Another open loop pole is there at S is equal to minus 2. Okay, so open loop pole, there are 2 open loop poles. One is marginally stable, another one is perfectly stable. Okay, so you are finding that one, so this first one, okay, so this first one open loop pole is at S is equal to 0 origin. Second open loop pole is equal to S is equal to minus 2. This is a stable pole. And there is a 0 here you are finding. Okay, so where is the 0? Open loop 0. Open loop 0 is at S is equal to minus 1. Now, what is the type of the system? So after you multiply GS and HS, check in the denominator how many S are there. So here there is only one S. Okay, had it been S square, it would have been type. It would have had a type of 2. But in this case, in GSHS, so very important concept. Type we find from GSHS. That is open loop transfer function. Here we are finding as S into S plus 2. So in this case, S raised to 1. That means this is a type 1 system because denominator is having only one pole in the origin. And for the same system, GS and HS, you find what is the closed loop transfer function. That is GS divided by 1 plus GS HS. Many such numerical we have done in block reduction technique. So we are finding this as GS by 1 plus GS HS. In that case, we are finding S plus 1 divided by S cube plus 3S square plus S. So there will be three denominator pole for the closed loop transfer function with negative feedback. That's why it has become 1. Okay, so this negative feedback is very important, otherwise pole will become unstable. So unstable pole or stable pole has nothing to do with order and type. Okay, so order and type is just a number, and stable and unstable depends on whether this sign is going to be plus or this sign is going to be minus. So whether it is going to be 1 plus or 1 minus, depending on that, the pole position would be situated either in the left hand side of S plane or in the right hand side of S plane. So in this case, closed loop system transfer function, there are three closed loop poles. That's why this system is going to be a order of 3. So this CLTF, because order we are find from closed loop system, so order of the system is 3, and there is a 0 here in the system. Where is the 0 of the system situated? The 0 of the system is situated at S is equal to minus 1. So zeros can be stable, zeros can be unstable. I have asked you actually in your experiment what is the effect of stable 0, what is the effect of unstable 0. So I'll check experiment number 4 right up, and I'll find out whether you have found the stable 0 and unstable 0 performance properly or not. So in this case, closed loop system transfer function is S cube, so it's a third order system, but GSHS was giving me S plus 1 divided by S into S plus 2. So in this case, as there was one separate separate pole at the origin, S raised to 1, so this system is having a type 1 system. So we have done 3 examples so far. First system, GSHS was 1 by S, so this is a type 1 system. Second system, GSHS was 1 by S plus 1, so S term was not there, separate S term was not there. S term is there in the denominator of OLTF, but separate S, only S square, S cube is not there in the denominator. So we assume this is S is to 0, that's why it's a type 0 system. Next, we are finding GS is having a square term in the denominator and HS equal to S. So if we multiply GS and HS, one of the S square gets cancelled. So at the denominator of GSHS, we are finding there is only one S. That means type of the system is equal to 1. And how can you find the order of the system? So put this thing into closed loop transfer function. You are finding this is S cube plus 3S square plus S. That means order of the system is equal to 3. So it's a type 1 order 3 system. Okay, so hence the system produced given by GSHS is a type 1 order 3 system. Next, let us find the order of the same system if positive and negative feedback is applied. So CLTF with positive feedback. CLTF with positive feedback, same thing. Okay, so whatever GS and HS are given here. So this is GS and this is HS. So positive feedback, we are finding S plus 1, S cube plus S square minus S. Okay, so here you are finding with negative feedback, it was S cube plus 3S square plus S. And with the positive feedback, we are finding that the closed loop transfer function is S cube plus S square minus S. So what we have found out from this numerical for the given GSHS, that is positive feedback or negative feedback, it does not change the order of the system. So here also with negative feedback, the order was 3. Here with the positive feedback, the order is 3. Okay, so let us find the order of the system with positive feedback is applied. So the order remains same, type also will remain same because type is not given by closed loop system, type is given by open loop transfer function. So CLTF order is 3 even if it is a positive feedback, and CLTF order is 3 even it's a negative feedback. So feedback does not change the order of the system. This is another conclusion. Okay, example 4. So this is another example. GSHS. So now I am not giving GS and HS separately. I have given GSHS directly. So in this case, S plus 1, S plus 2 into S minus 3. So here this is an open loop transfer function. So here there is one open loop 0, that is at S is equal to minus 1. There are two open loop poles. One is at stable pole and another is at unstable pole. So this pole is at S is equal to minus 2 and this pole is at S is equal to 3. So this is a system with type 0. This you have to understand because S plus 1 by S plus 2, S plus 3. How many S are there which are there at origin? So this is S raised to 0. So this is the extra term I have added just to show you what is the power of s at the denominator. Okay, so s raised to 0 is always 1, anything raised to 0 is 1. So in this case, this is the closed loop transfer function GSHS, that is s plus 1 by s plus 2 into s minus 3. So there is no separate s term in the denominator. That means I can substitute that as s raised to 0. That means this is a system which is having open loop transfer function as s plus 1 by s plus 2 into s minus 3. This system is having a type of the system as s raised to 0 is equal to 1. So type of the system is equal to 0 because there is no s which is existing at the origin when you are finding GSHS. So very important concept is this type, and just looking at the type and the type of the input, I can tell you how much is going to be its steady state error. So that is the art that I'll tell you. So for a given system, GSHS, so now I am not giving you GS and HS separately. I'm just giving you GSHS because we now know what is meant by type. So for a given system, GSHS, that is the open loop transfer function, S into S plus 1 divided by S cube S plus 2 S minus 3. So this S and S cube gets cancelled. So it is now S square into S plus 2 into S minus 3. So this is the open loop transfer function, GSHS. In that case, in the denominator, we are finding there are 3s, or there are 4s rather, not 3s. There are 4s. So one is at minus 2, another s is there at s equal to 3. But there are 2s which are at origin. This is very important. Okay, so this part is actually determining what is meant by type. So type is determined by open loop transfer function poles which are there at origin. So here we are finding this open loop transfer function GSHS, and there are two poles at origin. Hence the system is having type is equal to 2, because in this case there was a s in the numerator, there was s cube in the denominator, they get cancelled. That means s square at the denominator, it is remaining only. So in this case, it is s square into s plus 2 into s minus 3. So there are only two poles at the origin for open loop transfer function. That's why there is a system with type of 2. Another example, feedback system is forward gain GS s into s plus 8 divided by s plus 6, and h is equal to 3 by s. So if you multiply them, you are finding the open loop transfer function is 3 into s plus 8 divided by s plus 6. So what is the type of the system? There is no separate s here after multiplication. So GS and HS, they are multiplied. So there was a s in the GS numerator, there is a s in the HS denominator, they cancel each other. So whenever we are finding GSHS, there is no separate s remaining at the denominator. That means this is a system with type 0. Okay, likewise. CLTF with negative feedback. CLTF with negative feedback, if you are doing for the same GS and HS, you are finding GS by 1 plus GSHS, you are finding it as 4s, s into s plus 8 divided by 4s plus 30. So what is the order of the denominator polynomial? Order of the denominator polynomial, maximum s is there as 1. So this is a order 1 system. In this case, order of the system is 1, and maximum power of numerator is s square, but denominator is having power of s as 1. So this is a system with order 1. CLTF with positive feedback, here also you are finding it is minus 2s minus 18, that is minus 2, if you take common it will be s plus 9. So in that case also denominator is having maximum power of s as 1. Okay, so one very important thing, that feedback type, that is positive and negative, it can be, it does not change the order of the system. The order of the system is actually number of energy storing element in the system. So either you take negative feedback or you take positive feedback. Both the cases, the order of the system remains same. So in this case, that is equal to 1. But yes, whenever you are finding the open loop transfer function, you are multiplying GS and HS. In that case, the s's get cancelled. So there is no s at the denominator now. Okay, so in that case, the type of the system will be equal to 0. Now if there was a s here, so now I'm telling you a very important thing. If there was a s here, so it was 3s into s plus 8 divided by s plus 6. So that s you can take to the denominator, it will be s to minus 1. So what will be the order of the system in that case? It will be order minus 1. Okay, so for that we are not going to do what is the steady state response. So steady state response we will see only for a positive ordered system. Okay, so for positive typed system, I'm sorry. In that case, if there is a s at the numerator, in that case it will be ss to minus 1, so type of the system will be minus 1. So in that case we are not going to find what is the steady state error for negative typed system. I'm sorry, I said order. Negative typed system we are not going to see, we will see only the positive typed system steady state error. So if there is a ss to 0, so in this case there is ss to 0, so type 0. If there was a s here, that means gshs, denominator there is one s, that means type is 1. GSHS denominator s square, type of the system is 2. So in each of these cases, what will be the steady state error, we will find out. Lastly, another example is given that forward path gain is 1 by s and feedback gain is 2s into s plus 5. If you multiply, GSHS will be 2 by s plus 5. So in this case, there is no separate s here. That's why we are going to say that the system is having type is equal to 0. Likewise, and if you are finding the closed loop transfer function, you will be finding it as s square plus 7s. So in this case, order is equal to 2. So order is found from, so last time I'm telling you, order we are finding from closed loop transfer function denominator, what is the highest power of s, and type we are finding from open loop transfer function, that is gs into hs, and we are not multiplying the denominator, we are keeping it in the factorized form, that is gshs denominator, and in that factorized form we are trying to find out how many s are there which are there at origin. So in one line, what is the definition of type? Definition of type is find open loop transfer function, see how many poles are there at origin in the open loop transfer function. That is actually equal to the count of type of the system. So with this understanding, I will go for how to find out the steady state error. So what is steady state error? So there was a lot of confusion regarding steady state error, and I appreciate that confusion, because initially you tried your way of understanding what is steady state error. So a lot of misconceptions are developed so far. There is nothing wrong in that, because once misconceptions develop, then only because so far officially we have not started what is called as steady state error. So now today we will not be able to finish it, but at least we will start with the concept of steady state error. Okay, and there will be definitely the same three things, that is input will be step, input will be ramp, and input will be parabolic. So there will be different systems with type 0, type 1, type 2, and with 3 inputs. So there will be a table of 3 by 3. So this table you have to remember very clearly, and you won't have to mug it up, because all of it will come through a very proper proof. That is, there are 3 inputs. That is, first one is unit step input, second one is ramp input, and third one is parabolic input. And what is the relationship between that? First, we are given with delta t, which is the impulse. If you integrate impulse over time, you get step. So this is a mool mantra of signals and systems, very important thing, you know it. First, we are given with a impulse input. If we integrate impulse, we get step. If we integrate step, we get ramp. If we integrate ramp, we get a parabolic. So I will tell you, you can write it down. First signal, base signal is impulse, delta t. If we integrate delta t, we get unit step, that is ut. If we integrate ut, we get ramp, that is tut. And if we integrate ramp, we get t square ut, or we call it t square by 2 ut, which is a parabolic input. And reverse we can come. So if you are given a parabolic input t square by 2, we differentiate it and we get a tut, that is a ramp. Again we differentiate it, we get ut, and again we differentiated ut, that is the unit step. If we differentiate, we get impulse input. So impulse, integrate step, integrate ramp, integrate parabolic. And from parabolic, how can you come to impulse? Just keep on differentiating. So if you differentiate parabolic, you will get a ramp input. Differentiate ramp, you will get a step input. Differentiate step, you will get a delta input, that is impulse input. Very important thing. So what will be our theory question? Theory question, or generally there are 3 systems. There is a type 0 system, that means denominator of GSHS will be having power of S as 0. Okay, so we have seen many examples just now. So in that case, whatever is the type 0 system, we will give all these 3 inputs to that. What are the inputs? First is unit step, second one is ramp, third one is parabolic, and we have to find out how much is the steady state error. Second system, it's a type 1 system, that is GSHS maybe 1 by S into S plus 1, like that. GSHS, that is open loop transfer function, it is 1 by S into S plus 1. So there is only one S at the denominator, that is there is only one pole which is there at origin of the system for GSHS. In that case, we will give first step input, then ramp input, then parabolic input. What are the steady state errors? And the third system is type 2 system. That means suppose GSHS is 1 by S square into S plus 1. Okay, so whenever there is a S square at the denominator of GSHS, that means it's a type 2 system. And 1 by S square into S plus 1, this is a system given GSHS, input unit step, input ramp, and input parabolic, and find out what are the steady state errors. So these are the three things we are going to see in coming days. It will not be over in one lecture, so we are slowly but steadily we will be finding out very small proofs and repetitive proofs, so don't get confused. So this is a proof we have already seen. RS is the input. Now we are actually going in error analysis of the system. So this is the last topic of module number 3. Both the first and second topic are still pending, some part of it, so we will do it whenever we get time after the IA, maybe next week. And let us start with the steady state error. So RS is the input, BS is the feedback. So we know BS is equal to CS into HS. So this kind of proof can be asked in your exam. So BS is equal to CS into HS. Now this RS minus BS is ES. So we are writing ES is equal to RS minus BS. That is RS minus CSHS. Now what is CS? CS is nothing but ES into GS. Now we have done many of these kinds in our block reduction technique and all, or signal flow graph. So we know so CS is equal to ES into GS. Substitute that in ES equation. So first we found ES is equal to RS minus BS. That is the set point minus the feedback. And BS you can substitute. This is a feedback signal is equal to output multiplied by the feedback gain. So BS is equal to HS into CS. Now this was initial equation. Now what you are doing is ES is equal to RS minus the CS you substitute with ES into GS. So ES is equal to RS minus HS into ES into GS. And now what you do is take these three terms together. So this is one term which is comprising three terms. You take it in the left side and take ES outside. So what you're finding is ES is equal to 1 plus GSHS is equal to RS. So RS is the input and ES is the output. So what you are finding is ES is the error signal. That is how much is the error produced by the system. So ES is nothing but command input minus feedback signal. So it's a closed loop system error which is given by RS. RS is the input, okay, and divided by 1 plus GSHS. So previously we found what is the HS equation. Okay, what is the HS equation? Or sorry, what is the output equation? CS. CS was equal to RS into G divided by 1 plus GH. So these two equations you should write in one place. We found out what was the CS. CS was the system output. So CS was RS into G divided by 1 plus GH. In this case, we are finding what is the system error with the positive feedback. Obviously, that's sorry with the negative feedback. That's why here is a positive sign. So system error with negative feedback is equal to RS divided by 1 plus GSHS. So CS is RS into GS divided by 1 plus GSHS, and error ES is equal to RS by 1 plus GSHS. So what is not here? The GS term is not here at the denominator. So you have to understand that. So error of a system is actually Laplace S domain is given by the above formula. So how to find the error in the system which is a closed loop system and which is having a negative feedback. So how to find the error? That is nothing but input divided by 1 plus what is GSHS called? GSHS is called as OLTF. So very important formula is this: ES is equal to input divided by 1 plus OLTF. This is the way we write this equation. So ES is equal to, that is system error in Laplace domain, that is equal to RS divided by 1 plus OLTF. And how can we find ET, small ET? You take the inverse Laplace of ES. If you are taking inverse Laplace of ES, what you are getting is ET. Okay, that is nothing but the time domain system error. So whatever steady state error you are finding, you have to do that ET at t is equal to infinity. So how can you find ET? You are finding ES. How can you find ES? ES is equal to RS by 1 plus GSHS, where RS is the Laplace domain of the input. So if you are giving unit step input, RS will be 1 by S. If you are giving delta input, RS will be equal to 1. If you are giving ramp input, this RS will be 1 by S square accordingly. And ES is equal to RS divided by 1 plus GSHS. GSHS is open loop transfer function. How can you get time domain error? So whatever error you are finding, that can be represented in Laplace domain by this ES. Time domain error can be found out by the inverse Laplace of ES, that is ET. I have given you how to find out the inverse Laplace if system is given in Laplace domain. So we have seen that code sims. After that, you define what is the system and then take I Laplace of that system. You are going to get what is the ET value. So tomorrow again we are going to do this steady state error related lab. That will be our experiment number 6. So there what we will do is we will generate systems and we will generate what is going to be its error. Okay, and that error we will take into infinity time. So t is equal to 0 and we will be finding that not t is equal to 0, that error will be finding at t is equal to infinity. And whenever the system is going at t is equal to infinity, whatever is the value of ET, that is called as steady state error. So whatever value of ET we are finding here, that ET value if you are trying to find at t is equal to infinity, then whatever value we get is called as steady state error. Okay, and we will be proving all the steady state errors that already you have found. So let us take an example. So example for a feedback system, G is equal to 1 by S plus 2, H is equal to 2. So what is the open loop transfer function? Open loop transfer function is 2 divided by S plus 1. Okay, so 2 divided by S plus 1 means what is the type of the system? Type of the system will be S to 0, because if you multiply GS and HS, there is no S, separate S. Separate S means S at origin. There is nothing like that. So there is only one S at the denominator, which is at S is equal to minus 1. Okay, so there is no S at the denominator of GSHS, which is there separately kept at origin. That means this system is having type is equal to 0. So this is a type 0 system. In this case, let us find what is the value of ES. So what is ES? ES is the error in Laplace domain, that is equal to RS divided by 1 plus GSHS. So CS by RS is G by 1 plus GH, but E is equal to R by 1 plus GH. So in that case, first find what is CS by RS. So CS by RS is G by 1 plus GH, and G is given 1 by S plus 1, H is given 2. So if you are plotting it here, what you are going to get is CS by RS, that is a system transfer function, is equal to S plus 3. That means it was a stable system previously, that is 2 by S plus 1. Okay, that was the open loop transfer function. So there was only one pole, that was at S is equal to minus 1. And closed loop system is also stable, and this is more stable. So if I say you that there are two transfer functions, one is having pole at minus 1, another is having pole at minus 3. Which system is more stable? So answer is 1 by S plus 3, that is S is equal to minus 3 is a more stable pole, because that pole is deep into j omega axis on a real axis. So previously, whenever the system was open, at that time the pole was at S is equal to minus 1. Negative feedback has taken the pole deep into j omega axis, because now the pole is at S is equal to minus 3. So this is a more stable pole. Now you give unit step input to the system. So what is the system? System error is given by R divided by 1 plus GH. Now R is 1 by S, because you give unit step input to the system UT and find out how much is the error. So I have given you the input as 1 by S. So this RS is substituted as 1 by S and 1 plus GS into HS. So 1 plus GS into HS is 1 by S plus 1. That is GS value, and HS value is 2. So you have now found what is ES. So how to find ES? ES is equal to RS, that is Laplace domain of UT, that is 1 by S, and 1 plus GSHS. So GSHS is 2 by S plus 1. This is not finding error by formula or trick or property. This is finding error by standard simple method. So what is the concept of steady state error? I'm going to explain through this. Okay. So ES is equal to you are finding 1 by S into 1 plus 2 by S plus 1. So now you just take this thing clearly. So this S plus 1 goes at the numerator, and S plus 1 plus 2 comes at the denominator. So this is S plus 1 by S plus 3 and 1 by S into this. Now there are two terms in the denominator, so you do partial fractions, so 1 by 3s plus 2 by 3 and all these things. And now whatever ET you are finding, so whatever ES we had found, it was like this, 1 by 3 into S. So what is the 1 by 3 into S in time domain? It is 1 by 3 into UT. So 1 by S means UT, which is nothing but unit step response, that is 1. And what is 2 by 3 s plus 3? That is 2 by 3 e raised to minus 3t. Likewise. So again, I'll tell you the process. Those who have missed maybe. So GS is given as 1 by s plus 1. HS equal to given as 2. Find error in Laplace domain. So this is RS divided by 1 plus GSHS. Direct formula substitution. I have to mention what is the type of input, because if input changes, your steady state error and error will change, because the error definition is difference between input and output. So if the same input, if we are giving unit step input, response of the system will be different, error characteristic will be different. If I am giving unit ramp input or parabolic input, in that case output response will be different, error characteristic will be different. So ET will be different for each different types of inputs, that is UT, RT, parabolic and all. So what I have done, I have just substituted the formula. So ES is equal to RS by 1 plus GSHS. RS is 1 by S and 1 plus GSHS is 2 by S plus 1. I have rationalized partial fraction. Then I have found what is ES. So ES is 1 by 3S plus 2 divided by 3 into S plus 3. Now take the inverse Laplace of this. It is 1 by 3 into UT, first part, and second part 2 by 3 e raised to minus 3t. So this system is having two parts. One part is a stable amplitude, okay, which is nothing but 1 by 3. And second part is actually falling from 1, it is falling to 0. So at t is equal to 0, how much is this amplitude? It is 2 by 3. Okay, now there are two parts, 1 by 3 ut and 2 by 3 e raised to minus 3t. This part is converging, you are finding. Converging means this part is going to fall to 0 when the t is going to infinity. So I am trying to give you the concept of steady state error. What is meant by steady state error? So this is error. In this error, substitute t is equal to infinity. Now this error is having two parts. One is constant part 1 by 3. So t can be anything. This part is going to remain constant at 1 by 3 because ut amplitude is 1. And this part is actually a time dependent part. So initially when t is equal to 0, this part is 2 by 3. So how much is the error initially? 1 by 3 plus 2 by 3, that is equal to 1. So initially at t is equal to 0, this part is always 1 by 3 and this part is 2 by 3 into e raised to 0, that is 1. That is initially the error is 1 by 3 plus 2 by 3 is equal to 1. As time is going by, this 1 by 3 part is constant and this 2 by 3 into e raised to minus 3t, this part will keep on decreasing. So at t is equal to infinity, if you substitute t is equal to infinity, what you will find is this part is going to become 0. The next part, which is a kind of a transient part. Okay, and initial, this part is actually a steady state part. So there are two parts in the error. One is a steady error and there is the time dependent error. So this time dependent part of the error is diminishing or reducing as time is increasing. So at t is equal to infinity, this part is 0. So how much is the error remaining? Error remaining is 1 by 3. So even if at t is equal to 0 it is there, at t is equal to infinity also it is there. So what is the value of ET at t is equal to infinity? That is 1 by 3. That is actually the concept of steady state error. So सीधा तरीके से जाओगे, this is the way we are finding steady state error. We know what is GS, we know what is HS, we know what is the type of input. So find ES, that is 1 by S divided by 1 plus GSHS. Find what is ES, take the inverse Laplace, find what is ET. Now in ET substitute t is equal to infinity. Whatever value is there, if it's a finite value, then you will be finding that that is actually the steady state error. So in this case, it is 1 by 3 ut plus 2 by 3 raised to minus 3t. This part is diminishing with respect to time, but this part 1 by 3 ut will always be there. So at t is equal to infinity, the next part becomes 0, but 1 by 3 remains. So this is nothing but the difference between input and output. So how much is the steady state error? 1 by 3. There is another one way. There is another way. So this formula we will see how to find out on the next day. So steady state system error ESS is equal to, so this is a formula. This is the Laplace domain formula. Previously whatever formula I had shown, that is find ET, and in ET substitute t is equal to infinity. So from ES find ET, substitute there t is equal to infinity. Whatever value you find, you will be getting the steady state error. But what is the formula in Laplace domain? So from the initial value, final value theorem, all those things you have done. So this is the final value theorem. So ES is given. ES is given. From there you are supposed to find out what is the steady state error in time domain for t is equal to infinity. So whenever t is equal to infinity, that becomes s is equal to 0. So what is the formula? Limit s tends to 0, s into ES. This is the formula for any type of system, for any input. So ESS is equal to, that is E steady state, limit S tends to 0, S into ES. So what is the ES? RS divided by 1 plus GSHS. So itna chota sa part samajh lo. I will stop here with this numerical. So limit S tends to 0, S. So these are all formula. Okay, now substitute what are the different values of RS, GSHS and everything. So what is RS? RS is nothing but we have found it is 1 by S. And what is 1 plus GSHS? Substitute that. So 1 plus GSHS will be something like this. You just do that calculation. So this S and this S gets cancelled. You will be finding it is 1 by 3 and substitute S is equal to 0. So there is no S term here. That means whatever is the ESS value, that will be is equal to 1 by 3. So we have found the same for the same system. We have found ESS by 3 different methods. First, we have found by a straight cut method, find ES, take the inverse Laplace, get ET, substitute t tends to infinity, and find steady state error is equal to 1 by 3. Steady state error is found in time domain, not in S domain. We are finding the steady state error in time domain with the help of ES in the Laplace domain. This is the greatness of this system. So we know ES and we are finding ET at t is equal to infinity. That is called as steady state error. So that was the first method, and second method is find system steady state error in time domain. So this ESS actually is ESS of t, and what is the formula? Limit S tends to 0, S into ES. Okay, so there substitute what is S, substitute what is ES. ES you have already found above, so that was S plus 1 divided by S into S plus 3. So ES already you have found this thing. So S plus 1 divided by S into S plus 3. So this is ES we have already found. Okay, so multiply S with that because this S is the formula. So you know what is the final value theorem. So S into ES. So that is S into S plus 1 divided by S into S plus 3. This S gets cancelled. Now substitute S is equal to 0 here. If you are getting stuck, numerator and denominator both are becoming 0 after substituting S is equal to 0, you have to apply L'Hospital's rule. So that thing always goes on. So in this case, if you substitute S and numerator denominator, 1 is becoming 1 and denominator is becoming 3. So limit S tends to 0, this is 1 by 3. So final value at t tends to infinity of error ET as 1 by 3. So only this much you do. I will upload only this